If we wanted to fly the solar sail to a different orbit, we could change the angle of the solar sail, in this case 150 degrees, and you can see the projected trajectory is to go to a higher orbit, which is more potential energy put into the solar sail. This could put us on a trajectory to reaching the equivalent orbit of Mars. The other artifact is that this is very slow, and so we can change. Right now, this period is that 120 seconds takes the Earth around the Sun once, so 120 seconds per year. We can increase the speed of the simulation to take this to 56 seconds per year, for example, and that will make the appearance of time to go much faster. You can see once the solar sail starts to get close to the orbit of Mars, then we need to start making adjustments to keep the sail into the circle of Mars, because we would ordinarily be flying on a elliptical orbit, and we want to try to make it more of a circle. So coming around the other side here, we'll have to start making adjustments to keep the sail onto the path, and so small adjustments will need to be made once we get into this new orbit. And so you can see I'm having to continually adjust the angle of the solar sail to get the orbit to match up, and then looks like I overshot by a couple of degrees, but it's pretty close to the orbit. You can tell when you're close, because the relative speed at the given orbit I have indicated here. So I'm within 99% of the same speed that Mars is going. And then if I set the solar sail angle to 0 and increase the speed of the simulation, you can see the orbit is pretty well matched. I can make some fine tunes, and we should be in approximately matched orbit with Mars.